right, so we're going to go through the problems that you solved on your own just to make sure that you're really awesome and that you got mostly correct answers and hopefully help you understand mistakes you made on the ones where you didn't get the correct answers. So number one for this entire thing, remember that a 1/2 power is the same as a square root, and a 1/3 power is the same as a cube root. So that's huge in understanding throughout this. Also, remember that we have to check for extraneous solutions to make sure that the answers that we're getting work. So, first problem, we've got 2x plus 5 raised to the 1/2 power equals 4. Now, if you like, you can rewrite the 1/2 powers as square roots, but you don't need to. I know that this is a square root, and so I know that the opposite operation of a square root is a squared. Now remember, like you learned in the video, you don't square things until that square root or 1/2 power term is by itself. But we can see here in number one that it is. So I'm going to go ahead and square this. Whatever I do to one side, I also have to do to the other. So I'm going to square both sides. The 1/2 power and the squared power undo each other. So I just have a plain old 2x plus 5. Then on the right side, 4 squared gives me 16. So now, very simple linear equation to solve. Get rid of the plus 5 by subtracting. And then 2x equals 11. Divide by 2, and x equals 11 halves. Remember that we are mature, big boys and girls in math now. Do not use a decimal here. Everything in simplest radical and fraction form, unless there was a decimal in the original problem, unless it's a word problem, or unless it told you specifically to use a decimal, which it didn't do here. So let's look at number 2. Here I have a square root problem again, and the square root term is by itself. So that means to undo square roots, I'm going to square both sides. So that gives me 2x minus 4 on the left. On the right side, be careful. Remember that in your calculator, if you don't put this -8 in parentheses, you're going to get the wrong answer. That's why I just always do these without a calculator. -8 times -8 is positive 64, not negative. So then I'm going to get x alone, first by adding 4 to both sides. That gives me 2x equals 68. Divide by the 2, and I get x equals 34. Oh my goodness, shame on me. On the last one, I totally forgot to check for my extraneous solution, which is super important. So over here, I would have done 2 times the 11 halves plus 5. This is all under the square root, and I'm seeing, does that equal 4? So this would be 11 plus 5, which is 16. Square root of 16 is 4. This guy's okay. Over here, I have the square root of 2 times 34 minus 4, and I'm seeing if that equals -8. So 68 minus 4 is 64. Square root of 64 is 8, which does not equal -8. Remember that unless you're solving, we don't put plus or minuses with those square roots. So this is a no, which means that solution was extraneous. Now remember, we don't write extraneous as the answer. I usually write it next to it. But in this case, because we only had one solution and it didn't work, our actual final answer is no solution. All right, number 3. So here is my square root term. It is by itself, so that means I can go ahead and square both sides. Now be careful over here on the left side. This is x plus 2 times x plus 2. There are so many of you who keep saying this is x squared plus 4. It is not. Rookie mistake. When you have a binomial times a binomial, you have to FOIL. So x times x is x squared. Outsides give me 2x. Inside terms give me 2x. And my last terms give me that plus 4. On the right side, when I square it, it just undoes the square root. So it gives me 5x plus 10, which I can bring down here. Now, these are like terms over here on the same side, so I'm going to combine those first before I start moving things from side to side. Remember, you learned in Algebra 1, it's always the best idea to simplify the individual sides of the equal signs first before you start moving things from side to side. So because this equation is quadratic, typically we solve quadratics by getting them equal to 0. So I'm going to move both of these terms over here, over to the other side so that I can have it equal to 0, because these two go away and I've got 0 on the right. So x squared, this gives me minus x. This gives me minus 6 equals 0. So now we spent so much time in Unit 2 reviewing how to solve quadratic equations. So here I'm going to try to factor it. So thinking about if there is something that multiplies to -6 and adds to -1, which, you know, -6, 1, -3, 2, and switching the signs. These ones do indeed add to -1, so it is factorable. X minus 3 times x plus 2, which this guy gives me x equals 3. This guy gives me x equals -2. So I need to check both of my solutions. So 3 plus 2 is 5. I'm seeing if that equals the square root of 5 times 3, which is 15 plus 10. So this would give me square root of 25, which is 5. So that one works. Now I look at the -2. -2 plus 2 would be 0 on the left side. On the right side, square root, I'd have 5 times -2, which is -10 plus 10, which is also 0. So yes, in this case, both of my solutions work. So I have 2 valid solutions there. All right, now this one is a little trickier because it's not a single radical problem. This one, I have 2 radical terms. When that happens to us, what you want to do is you want to get them on opposite sides. So I'm going to move this 2 radical x to the other side by adding it. So now I have square root of 12 minus 2x equals 2 radical x. So once I've done that, this radical is by itself, so I'm going to go ahead and square both sides. Now again, we're trying to show you all the tricky situations so that hopefully you're well prepared for everything and you're not going to get tricked on the quiz. So here, square root and squared undo each other, so 12 minus 2x. On the right side, be careful. This 2 is not under the square root, so that 2 needs squared, which gives me 4. The square root of x squared is just x, because the square root and the squared undo each other there. So now I want to solve this for x, so get all my x's to one side over here. I've got 12 equals 6x, which would give me x equals 2. Again, we always want to go back and check it. So square root of 12 minus 2 times 2, which is 4. And then, just messed up there, minus 2 square root of 2. And we're seeing if that equals 0. So 12 minus 4 is 8, square root of 8 minus 2 radical 2. We're seeing if that equals 0. Now you could certainly just check this on your calculator. You don't have to do this by hand, but just to quickly review, if we were breaking down this radical, it would be 2 radical 2. So this is true. My solution is good. All right, number 5. Here I have a cube root this time. There's just one of them. So first step is to get that cube root all by itself. So I'm going to subtract 3 on both sides. That gives me cube root of x equals 2. Now, because this is a cube root and not a square root, that means that to undo that cube root, I'm going to cube both sides. So the cube root and the cube undo each other to give me the x here. 2 cubed, remember this isn't 2 times 3, it's 2 to the third power, which is 8. So check it, cube root of 8 is 2, 2 plus 3 does indeed equal 5. So x equals 8 is my solution there. So now subtract the 2 over here on number 6 because this 1/3 power is my square or my cube root. So I've got x plus 5 to the 1/3. And I've now got that alone equals 1. So 1/3 power, same as a cube root, so I undo it by cubing. Whatever I do on the left, I also do on the right. So cube root and cubed go away. I just have x plus 5. 1 to the third power is just 1. So to keep solving, subtract the 5. That gives me x equals -4. And then I'm going to check it. So 2 plus the cube root of -4 plus 5, and I'm seeing if that equals 3. So -4 plus 5 is 1, so 2 plus cube root of 1. Cube root of 1 is 1, so yes, that is 3. Solution looks great. Almost there, number 7. Now, in this case, I only have a single cube root. Here, up in number 4, we had 2 of them, which is why I had to leave this 2 attached because it was going to end up on one or the other of them. Here I only have 1, so we should begin by dividing by 3 to get my cube root all by itself. So that gives me cube root of 2x equals 4. Now I'm going to cube both sides. That gives me 2x equals, remember it's not 4 times 3, it's 4 to the third power, which is 64. Divide by 2, and I get x equals 32. Again, all of these checks you can certainly do on your graphing calculator or a scientific calculator if you want. I'm just, it's a little bit quicker to not switch screens. So 3 times the cube root of 2 times 32, which is 64, and we're seeing if that equals 12. So cube root of 64 is 4, 3 times 4 is indeed 12. So you can see most of our solutions work, but there's always, a couple in there that don't. All right, very last one. I need to get this 1/3 power all by itself. So subtract 4 on both sides. That gives me x minus 1 to the 1/3 power equals -2. So 1/3 power, to get rid of that, I'm going to take it to the third power. This has a negative, so that's why I'm enclosing parentheses before my exponent. Because remember, if you don't, you're going to get a different answer. And I'm just going to illustrate that here in a second for you as well, just to remind you what ends up happening. So here, if I do -2 to the third power, and actually I'm going to illustrate it with a squared, but -2, because my squared button is quicker. If I do it in parentheses, I get 4. If I do -2 and then just hit squared and hit enter, it tells me -4. Because order of operations here is doing the exponent first and then multiplying by the -1. So when you have negatives and exponents, the good rule of thumb is to always use parentheses. On odd exponents, it does end up being the same, but on evens, it does not. So here, we just end up with x minus 1 on the left. -2 times -2 times -2 is -8 on the right. So then solve for x by adding 1 to both sides, which gives me x equals -7. So then I'm going to check it. My last one, 4 plus cube root of -7 minus 1, and we're seeing if that equals 2. So cube root of -8 is -2. 4 plus -2 is indeed 2. So there we go. Hopefully, you understand anything that you missed the first time, so you can always go back and re-practice some of these if you want, and then you also have a quizzes practice you could do as well.